Hey guys, Mr. Thibodeau here. So, lesson 9, prime numbers. So prime numbers are interesting because we're still finding new ones of these. Anyway, you're starting with your mental math. You're going into problem solving. Okay. Then, prime numbers, lesson 9. All right, the new concept is a prime number is a number that only has two factors. And those factors are 1 and itself. They only have the identity, the multiplication identity rule, where it's just the only way to get that number using whole numbers is 1 and 5, right? So, or sorry, 1 and the number itself. So for 5, yes, I could do 2 times 2.5. However, that doesn't cut it for a prime number. For a prime number, we're only looking at the whole numbers that can be multiplied together to get the number, okay? The only way to get 2 is 1 times 2. The only way to get 3 is 1 times 3. The only way to get 5 is 1 times 5, okay? These are numbers that have no other factors, okay? We may use an area model to illustrate numbers that are prime and numbers that are not prime. So suppose you have a 6 square tiles. You can move those around to make different rectangles, okay? And this is what we talked about last lesson with trying to figure out different rectangles. But now with a prime number, this is the only rectangle I can make that is still a solid rectangle. If you try to put it together any other way, you're going to have a piece left over. Okay. So, what is prime factorization? Composite numbers are named because they have composed of 2 or more prime factors. For example, so there's prime numbers, which are ones that have only the one factor, 1 in itself. And then there's composite numbers, which have many factors, okay? And then prime factorization is our ability to kind of break that apart, okay, and talk about that. So, prime factorization is how we break 36 up into and show all of its other factors, okay? Specifically, when we're looking and we break it down to its prime parts, okay? 2 and 3 are prime, so you cannot break that down any further, okay? This becomes important when we're talking about breaking down square roots or other things like that, okay? Prime factorization of 6 or 36, you can break that into 2, 3, 2, and 3. Okay. A good, especially for evens, a good way of breaking it down to get your prime factorization is to just, you're making this like number tree, it's just cut it in half. Odd ones, you're going to struggle a little bit more. You're going to look for whatever number you know can divide into it. Okay. So 5 and 45, you can bust that into yeah, just constantly dividing the number by any prime numbers is a good way to do this. So you have 45. You know that 5 is a prime number, so you divide it by 5. Okay. Anytime you can take a prime number out of it, you're going to do good. Okay. Which is why dividing things by 2 is also a good use. So one way to test if a counting number is prime or composite is permanent if it is divisible. Is it prime or is it even? Then it's absolutely divisible by 2, right? So it has another factor. Can the sum of its digits be divided by 3? So 3, 4, 2, 0. 3 plus 4 plus 2 plus 0 equals 9. Just knowing that's 9, I know that 3 can easily divide into this. If the number ends in a 0 or a 5, then it is divisible by 5. Okay. So here we would see if this is divisible by 3, we would do 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 7 is 13, plus 5 is 18, plus 2 is 20, plus 6 is 26. Is 26 divisible by 3? No, it is not. So this cannot be divided by 3. But it can be divided by 2, okay? Because 6 is even. So this is a composite number. This over here, 5 plus 2 is 7. 7 plus 6 is 13, 14, 15. 15 can be divided by 3, so I do know that this number has another factor, which is 3. Okay. All right, so for our practice set here, let's go ahead. We'll do 1 through 5. Ooh, I should only have you do prime numbers. No, that'd be too little. 1 through 5. And then I want you to do 12 through 15. And then 16 through 30 even. Okay. All right, guys. That's the lesson for today.